Hello, you are now listening to the Modem Podcast, where we deconstruct, examine, and discuss deeply technical data networking and information technology topics. Sit back and relax while we fire up Dial D and the 9600 baud modem and connect to the Wildcat BBS.
Hello and welcome to another IPv6 related version of the Modem Podcast. Today we've got special guest. I'm channeling my Chris Roberts from the 9 Club skateboarding podcast that no one will listen to. But we've got Ed Horley.
Yeah, which of course means now that this turned into the special ed session, which is not what we wanted, but whatever. It's all good.
We've got Ed of a little podcast that folks may or may not have heard of on the Packet Pushers Network. It's called the IPv6 Buzz. If you haven't checked it out, you should definitely check it out because it's worth checking out. And we're going to talk about something that is either the worst thing or the greatest thing in the world. I think it's the worst. And we're going to go into why that is because I've got opinions on things. But to keep me on track, as always, is Chris Cummings and Chris Young. So what did we say it is? The crises?
The crises, yeah.
Yeah.
C2.
C2?
Yeah, C2.
Command and control.
C3. I mean, I'm Chris Cummings, so I've got another C here. And you got one.
Okay. Okay, that's something. I was going to go down a deep hole there, but I'm not gonna. So, yeah.
Well, what are we talking about? What are we talking about today?
We're going to talk about ULA today.
All right.
First, I want to know how you're doing, Ed.
User licensing agreements, is that?
Yes.
It's going to be awesome.
Yes. I want to know how everybody's doing, starting with Ed. Ed, how you doing today?
Well, COVID recovery is always a fun enjoyment time, but hey, I'm on the mend, so that's good. But, working on V6 projects. So, what else can I say? Just spending the majority of my life advising clients not to use ULA.
Living the dream, baby.
Yes, totally. Not to give away the ending, but there you go.
Yeah. So
don't
Chris
bury
Young.
the lead.
Chris Young, how you doing?
I am doing excellent. This is, what do we say, probably 2 years since I've last seen Ed's lovely face.
Yeah, it's been a long time.
And had the opportunity to just kind of hang out. So, less travel, but it's good to be here.
It is good to
Little
be here.
IPv6. I've got IPv6 actually running, thread networks and all that good stuff. So it's finally the year of IPv6 as far as I'm concerned.
All right. Yeah, we did that podcast on Thread. We'll link to that too. That's a good one. Fully V6 compliant and native application. That's very cool. So
running RIP for the win.
Hey man, it's old is new again. At least it's probably RIP 2 or RIP NG. But
I thought Thread supported Ripple too, doesn't it? Who knows? It might do that for the mesh side. So I'll have to check.
It does some special stuff, which is hop-based variant on total number of counts that is not actually RIP NG, but it is close enough to, yeah.
It's derivative.
It's a distance vector, we'll call it that.
Yeah. How you doing, Chris Cummings?
Oh, man, it is coming down snow here where I'm at. And where you're at, obviously. But, yeah, I don't know. Going to go shovel snow after this, get a little workout in. Anything to get away from computers, I guess. But yeah. I overall, I'm doing pretty good. Actually, I started a new job recently. I now no longer have or can call myself a network operator. I'm now a software weenie, as my boss, I think, would refer to it, being a software weenie.
You've moved categories. Who moved my cheese?
Recovering network operator.
He's automating the things at the same place. So same employer, just new.
Destroy at scale.
Yeah, I'm just going to break things faster. I was really getting tired of how reliable networks are. I just feel like networks, they've kind of been running well for a while and they've had a good run. And I feel like we need to spice that up. So let's throw some new stuff in here.
You're going to deploy ULA at scale is what you're telling me.
Yeah. I'm just going to do it. I got a Perl script that does that. It's written with a little bit of Ruby as well.
Yep. Chris Young helped. He made all the writes are done with SNMP sets.
Oh no!
And
I mean, I've done
They're
it
all
in
one line.
Perl.
They're all one-line regex, so it's all good. It's going to work perfect every single time.
It wouldn't be a podcast with Chris Young if we didn't get a SNMP jab in there.
I know. I got it right away.
Man.
You can call it out what it is, but you have no other choice. You'll still end up there in the end. At the end of time, cockroaches, Twinkies, and SNMP.
I think you're probably right. I would eat 2 of those things, neither of which are SNMP. All right. Let's dive right into this. ULA, boy, it's a thing. And I think, with the surge of V6 that's been happening in the last probably 18 months or so, I've seen a pretty big uptick in V6 deployments, V6 questions, just general V6-ness has been increasing. And one of the questions that I get inevitably, especially from enterprise style, campus style networks where they're used to being able to use RFC 1918 spaces, they make that jump as soon as they read about it to ULA space. So I think it's important to call out what that is and what it's for and what it's not for. So I'm gonna pass the torch over to Ed here, and I want to hear Ed give us his take on those questions in his velvety recovery voice that he's got going on here.
Well, Ed, isn't ULA just RFC 1918 for IPv6? I mean, isn't that the end of the podcast?
It's a little bit more complex than that because ULA actually changed functions with an RFC update. And I actually think ULA was a little bit more practical before that RFC update happened. So maybe I give a little bit of history there just to put things in context for everyone. So ULA, from a starting standpoint, is an address range that has been set aside as part of an RFC. It's FC00::7. And part of the RFC.
If you wouldn't mind me interrupting, what does ULA actually stand for the people at home?
Oh, yeah. It's a unique local addressing. So it's designed to be used within a non-global scoped network, right? So it's not something that you're going to use to talk to the internet. It's not going to be something you use to, functionally get out and even NAT translate to something on the internet. It's not really its function. Its function is to, be bound locally but unique within that local space, right? So so unlike link local addresses, which you could technically have the same FE80::1 on every single router interface because it's just the default gateway, but it's only locally scoped. With ULA, you would have a unique one on every single interface because it has to be unique within that local scoping. Anyway, hopefully that sort of explains quick.
Yeah, and I think that description of it really hammers home why folks gravitate towards it when they're looking for an analog for RFC 1918 space.
Yeah, it looks very similar. Like if you step back from the 30, 50,000 foot view and you're an architect and you're saying like, I want to take the same principles that I used because I think I'm an awesome V4 architect and I want to take the exact same awesome V4 architecture things that I already know and love and apply them to V6 because I'm lazy and I don't want to learn the V6 architecture. That's what you're going to do by default. That's just the natural habit. And I don't blame anyone for that. I get it. Like you're going to have to build something analogous to what you're already doing today. And that's an easy lift. And so a lot of people see that one very quickly and they default to I should do what I do in V4. I should NAT all the things. I'm going to use a local address space within my network and it'll be unique within, just within our network topology of what we operate as operators. But to the rest of the public internet, I'm going to NAT to some other global prefix. I'm going to do that at the same location that I'm used to doing that with V4, which probably means some sort of stateful firewall where I'll do NAT and stateful packet inspection at the same locations. And so they just see a lot of analogy there, so they go for it. But the reality is they probably were not doing their homework. They didn't read the RFC for ULA, which is 4193. So they don't understand the binding and scopings of it. And then they also don't understand RFC 6724, which is the update to 3484, which was a major change about how ULA performs on host operating systems. And so that's what I guess my original point back a few ago was what's the RFC that changed how ULA operated? And that was RFC 6724. And that RFC actually dictates on host operating systems how source and destination address selection actually works for both protocols, v4 and v6, by the way. And that's actually important for ULA because what happened is we actually took the preference of ULA and sort of demoted it in terms of usefulness. So before it had a different weight characteristic or a different precedence characteristic within 3484 that actually meant that you sort of went IPv6 global unicast addresses, then you went ULA, then you went to a bunch of other things. So ULA was sort of an equal citizen to just regular IPv6. After 6724, we actually demoted it, and it actually became less preferred than IPv4. So when you're going through and you're actually trying to select source and destination address locations to build a session from one host to the other, both operating systems are going to go through a set ordered list, right, of selecting things, and it's going to say, oh, I'm going to use global unicast address space first. And in this case, if you got ULA and you think it's going to use ULA next, it's not. It's going to go to IPv4 if you got IPv4 enabled, and then it's going to go to ULA. So even if you're publishing ULA addresses in your DNS, it doesn't matter. It's going to fall back to v4 before it goes and use ULA, which effectively means ULA is in any dual stack network is functionally useless. It's not going to do anything. I mean, it might be there as a backup in case your v4 doesn't work. So it's not really useful. And the reason I say this is a big structural mistake is that there are many people who want to do the analogy that we talked about, which is using v4 and v6 together. And we want to use the same analogy with RFC 1918 to ULA. So they'll deploy their internal network as ULA only and say, like, I'm going to use MPT v6 or I'm going to use NAT66 at the edge, and I have my global unicast there. And they're like, yeah, I've dual stacked my network and I've got v6 working. You really don't. You have v4 operating. Nothing's going to switch over and use v6 with ULA because guess what? It's not preferred. So the only time you're ever going to see v6 traffic is not until all your v4 fails.
Right.
That actually sounds worse than useless because it's consuming resources, consuming OpEx, engineering time, and it's never going to get used. And
well, it doesn't get you to the
argue,
goal, right? Which is to adopt v6, right?
Well,
right. And wait, Chris, because there's more.
And I would also argue that at the end of it, it's not going to work because it never got tested.
Yeah, that's one of the big structural problems.
Even the worse.
Yeah, that's even worse in many ways because to even get to test ULA, you have to functionally fail v4, which not a lot of shops are really willing to do. So it becomes this interesting use case. I mean, if you want to test global unicast addresses, because it's preferred in the OS, it's going to start using it right away. If it's not working for you, you simply just shut it off and it'll flip back to v4.
Something important that you said there that I don't know that a lot of people actually understand or even really know is that there's a preference for how addressing is used within a given operating system. And there are ways to change it on certain operating systems. And then there are other operating systems where there is absolutely no way to change it.
Or it's incredibly painful to do. Yeah. I mean, look, we can go in and do kernel changes and you can recompile your kernel based off of the changes you do. So
right. But like on operating systems like Linux, there's a file. You can go and look at that file and they'll tell you like what order things are going to happen in. Mm-hmm. I assume there's probably ways to do that in Windows. I don't know of a way to do that in Mac. But like you said, if you've got global unicast v6 addressing and ULA and IPv4, the order is not what you think it will be. Well, not what most people think it will be. And I think that's a very important distinction to make for someone that needs to test their IPv6, because the easiest way to do that is go generate a ULA block and do that. Mm-hmm. What they don't understand is exactly what you just said. If you're dual stacking it, you're never going to test it. And they probably won't know that. It's hard to see unless you're looking for it.
Yeah, and you had some great examples that you posted. So for those that don't know, Chris and Nick and I all participate in the v6 ops mailing list for the ITF, and we've been Nick posted some very useful sort of outputs to sort of demonstrate to folks what exactly was happening around ULA preferences versus global unicast addresses, because even folks in the ITF don't necessarily believe the statements that we're making in regards to the functional problems, operational problems with ULA. I think architects get super excited about ULA because of the analogies with RFC 1918, some of the flexibilities around design, and I totally get it. I understand the attractiveness of it. But anyone who's an operator Like you look at ULA and you look at what behaviors you're getting out of it, and that is not the sort of consistency you want running around in your network. Like there's no part of that I want, to rely on in order to make sure that I'm getting session connections going from one side of my network to the other. And to have operating systems making random decisions about that is even worse. What's really strange is because of the change from RFC 3484 to 6724, if you have substantially older operating systems, they will behave differently than the newer operating systems, which causes even more weirdness within your network. So it's a real challenge. And so just avoiding ULA outright, you will always get consistent behavior if you use global unicast addresses. Every single time, you're going to get consistent behavior.
Yes.
You're not going to get that with ULA.
To take it one step further, it's also application specific as written into the RFC. So different applications, if you say you have a DNS address that has two quad A's, one's ULA, one's GUA, and an IPv4 address, the application that you're using chooses which one of those to use with regards to ULA. So it can get even less consistent based on application support. And I think that's one of the most broken things within the ULA design is that they made it flexible, but it's now incredibly inconsistent.
Yeah. I would say that's the greatest challenge for operators. Super flexible, so architects love it, right? It's like, oh, look at all the things I can do, and if I want to override that, my application team can go and do that. I think for operators, it's nothing but screaming nightmare and pull your hair out because everyone's opening up trouble tickets saying like, why isn't this working the way I think it should work? And you have very little control. It's the same structural problem, and this was even admitted by both. Dan Wing and Andrei Yurchenko, who wrote Happy Eyeballs. Happy Eyeballs introduces a whole set of problems structurally around debugging what's going on with IPv6. It is awesome for all the things around making the end user experience fantastic for failing over between v4 and v6 and operationally making that as smooth as possible for the end user. But for the operator, you have not a clue what the heck is going on. You don't know if the local OS is doing something. You don't know if it's the app, like the browsers are doing something specific. You don't know how it's gluing together the page, if it's combining v4 and v6, which one it's preferring. So the consistency side is very, very difficult from a Happy Eyeballs transition standpoint. And that was recognized early on. It was an accepted structural problem with Happy Eyeballs. I just don't think people really realized that with ULA at the time. ULA was sort of changed from a status basis in RFC 6724 for the operational challenges and hardships that we would all endure to try and get, ULA to be something functionally useful. And I sort of question even, the functional usefulness of it now, given the, just huge amount of address space you can have with global unicast addresses in v6. It's sort of like, well, why would you even bother with ULA? And I suppose we can try and answer that question. I don't know if I would have any good answers. I mean, there's very, very, very few use cases around ULA that functionally and practically make sense. We can talk about those few that I think exist, and almost none of them apply to global enterprises that are trying to deploy IPv6 right now. So,
I think the easy answer is transference of mental models from IPv4.
Yeah. I mean, 100%, Chris. You're exactly right. I mean, it is hitting the big easy button in terms of like, sort of changing over what your architecture is from one protocol to the other, without question. But beyond that, I want someone to argue. Someone take a devil advocate view. What's the argument for why you would want to use ULA? Nick.
I think if I was going to play the devil's advocate, I would say I'm going to run an IPv6 only network, and for some reason I have a policy or something that says I cannot run global address space on my internal network. So I run ULA, no IPv4, and I do a translation box at the edge.
Yeah, so that's an interesting point. So here I'm going to bring up a couple things, and I want to hear your response on that, because I don't necessarily disagree with your thought process on that, but I do have a question in regards to dealing with turning off IPv4. While that's possible to do in the Linux operating system, because they still keep them as dual protocol, it's dual IP layer in Windows. And in Windows, it's not possible to turn v4 off, which means every single host operating system is still going to get a PIPA address and think it has working IPv4. And guess what? it's going to try and use all that at PIPA way before it ever tries to use ULA. So you're back in the same situation where you're going to use your global unicast, then you're going to fail to IPv4, and then ULA is at the bottom of that list. And so you're going to deal with all sorts of timeouts, operational issues, which gets back to my original point. Operations nightmare because you can't turn it off for Windows. So where are we at? Like, and I understand the answer is, don't run Windows, but at the same time, I think it becomes a very difficult situation operationally for big enterprises to say, I'm never going to run Windows. And so
I don't think that's realistic. Now, I will fully admit that my experience with running V6 only, I have one Windows machine in there and it works fine. I never have any problems with it. But everything else is either Linux or Apple or an embedded device. And I don't really run into those problems. I have seen on the Windows machine where it will happy eyeballs to whatever it is that I'm trying to do. Now there's a NAT64 at the edge, but I will again admit that use case was a stretch. I wouldn't do it that way. I would just do GUA addresses and create appropriate firewall / filtering at my edges.
Yeah, routing rules. There's no requirement that you have to route all of your global unicast address space out to the public internet. Like there's zero requirement to do that.
Yep.
So just whatever, take your /32 and whack it in half, and the 33 is what you advertise to the outside world, and half the 33 you just don't route to the outside world and do whatever you need to. And you could build a 1-for-1 for every single, network you have in the 33. You have another one in the 33 that's not routable. I mean, that's perfectly doable also. So there's all sorts of options.
Yeah. And I did a talk, like 10 years ago or so, where it was basically, it wasn't related to this, but it was essentially coming out to say like routing is the sledgehammer for a lot of these security policies. We've been using it in the WAN for a long time for black holing, but you can also do it for things like, I don't want that to be globally routed, so I don't globally route it. And I think that's a very reasonable architecture to deploy. But, as far as finding use cases for ULA, I've purposely used it. So I've gone out of my way to actually build it into both networks that I'm using on a daily basis and in lots and lots of labs. And I really struggle to find any great use for ULA because it is so far down on the preference list that it's functionally useless.
Right. I would agree with that. I would say there's a couple use cases that make sense operationally. If you've got networks that are fully siloed and never going to touch the internet and never need to touch the internet, hopefully there are a couple that are running out there that people are doing this intentionally, like, I don't know, nuclear plant facilities, things that should never be on the internet. I could understand, maybe some special use cases for military applications where it makes sense for them and they're designing very specific networks around the use case for it. And interestingly enough, one of our favorite sideline topics, too bad Kevin isn't here, but zero tier. Zero tier is doing some interesting stuff with ULA. Strangely enough, in the FC space, as opposed to, both the FC and the FD space. I think that's the other space that, for software developers, there's definitely some interesting use cases with folks that are building solutions like zero tier that it might operationally make sense for them to be able to make use of ULA for the reason of, I'm not trying to provide a global unicast, globally accessible address space. I'm trying to provide something to allow people to build dynamic sort of peer-to-peer networks, on demand. And I need them to auto-provision, auto-address, and I need to have an address space to do that out of. And link local is really not the right answer in those use cases. And I don't want to have to go out and get a large, /24 from one of the RIRs to figure out how to build a large enough global unicast.
That's a good point. I could see ULA being used as a software developer to just as a placeholder for making sure my IPv6 code actually runs.
Yeah.
To validate that code path.
I think even then, though, it's still fraught with issues because unless you're developing for IPv6 only, it's still going to cause issues. And as much as I would love that, like, the use case you gave earlier about like an isolated nuclear plant or something like that, like even now, those are still going to all have, dual stack at best, right? There's still going to be a IPv4 component, and then,
still exploitable is what you're telling me.
For anybody who can't see the look on
shocker.
my face, I'm throwing up in my mouth. Did you just seriously, with a straight face, say developers temporarily using something for testing?
Yeah, right.
No,
yeah, I can now say
developers using the address space to validate that.
Yeah,
you can write
did
testing
you just say
rules.
temporary? Yeah,
Well,
that's going into production. We've all done this enough.
Right. I think the other side is there is global unicast address space that's been set aside for documentation purposes that you could use for the exact same test harness reason. So I think you could use that. I think there needs to be additional address space that's sort of set aside, and we can park and talk about that here a little bit later. But a /32 of documentation address space just isn't sufficient anymore. Given where we're at and given what we're seeing enterprises do from an adoption standpoint for their need requirements, even around public cloud, it's just not acceptable in terms of enough address space. At least my humble opinion. So
if I can take us back for a second, because there's one thing that's flown around in my head. We've talked a lot about how RFCs have changed. We've all done this enough to know that the magic blessing of an RFC by the IETF does not ever mean it ever gets implemented anywhere. So it obviously has been implemented in some places. But the biggest concern that I've got right now, after listening to this whole conversation, is the complete lack of predictability about the design, because old stack behavior, ULA behavior, versus new stack ULA behavior. So where, from what you guys are looking at, of what's actually in the wild, developed and pushed out, where are we with that transition to the new style behavior, sub IPv4 versus the ULA IPv6 sandwich, if you will?
Yeah. So just to sort of reassure you, RFC 6724 came out September 2012. So pretty much all major operating systems current today are all 6724 compliant. It's a very small change between 3484. So 3484 originally came out in February 2003. So that's, you wouldn't have seen anything predating that in terms of sort of like V6 default behavior, except for what you loaded in the stack. And then 3484 came out. You would have followed those guidelines past that. And then I can't think of anything that's currently doing 3484, except for if you have really old Windows and Linux systems laying around that were prior to maybe 2013, 2014 or so. From a behavior standpoint, it got updated very, very quickly because it was a pretty minor update for folks to do. On the OS side, and they actually pushed it out pretty quickly because there was a lot of flurry of activity going around V6 in that 2014, 2015 timeframe. If everyone sort of remembered, there was a lot of activity that was going on there from the service provider adoption basis and a bunch of others. So this made it out into code for operating systems pretty quickly. So I'm not as nervous about that. I pretty much assume that everything is running 6724 as a default behavior, just as my standard now, Chris, just sort of across the board for any customers we're dealing with. I just think it's just structurally so broken now that it's not a practical tool to have in the tool belt unless you really have a very, very, very narrow use case around what you want to do with it. And those use cases aren't compelling to me anymore. So I pretty much tell all our customers, that's not the direction that they should be going. They should be using global unicast addresses because guess what? It's guaranteed to be globally unique. And you can do all the things that you would ever want to do with ULA with global unicast addresses, including not bothering to route them to the public internet. Like that's a perfectly feasible thing to do. So you're in the exact same position as you were with ULA. You just are guaranteeing that you're globally unique and that you can assign a single global unicast address to an interface and not have to deal with a global unicast, a ULA, a link local, a solicited no multicast address, and like how many other addresses do we want to add on there just to make your life more complex? So I think from a simplicity standpoint, I just prefer to use global unicast addresses everywhere for every purpose that you can possibly think of. It just logically makes more sense to me, and the topology makes a lot more sense when you're looking at it. It's just much more.
Yeah, I'm with you on that one, Ed. Like, I mean, the whole point of IPv6 was give us more address. Not the entire point. Okay, I'm not one of those people that says it's just V4 with more bits. It's a lot more than that. But like, one of the main benefits of V6 is we have so much address space, and that's the huge paradigm shift between V4 and V6, right? Like, yep. I know so many people when they first, start getting into the world of V6, they go, "Oh wow, well, I don't want to put a /64. Like, how big of a subnet should I put on that interface? Well, I might have 200 hosts. Well, okay, well maybe I could do like a slash." Yeah, /120, or I could go a little bit bigger, but I don't want, well, how big does my broadcast domain have to be? And then it's like, no, that's not the point. /64s. That's all you got to know.
And there's no broadcast domains.
Yeah,
that's the other
exactly.
part.
Yep, yeah. Exactly. It's just, there is so much of this old IPv4 mindset that's applied to V6, and address scarcity is a big one.
Yeah, I get it. It's hard to move away from that. We call it V4 thinking. That's what we call it internally, is we call it V4 thinking. And it's very hard to break away from V4 thinking because it's the only way operational, unless you were super old, like, some of us on here that, remember our IPX days and SNA and ATM and everything else. But I just don't think there's a proper analogy about how significantly different V4 is from V6. It's hard for people to grasp. You're really only worrying about networks. You don't worry about how many hosts you have in a given segment at all. It's just not an issue that you even think about. You just worry about how many networks you want to operate. And even then, it's hard for people to fathom how many networks you can really operate with the amount of address space that people really should be getting and asking for. I think that's the other great mistake is people just don't ask for enough address space, and then they want to solve the problem by saying like, oh, we got assigned a 40. That's not enough address. I get done doing my network build. It's not enough. So I'll deploy ULA instead and do network address translation to the global address space that I do have. So I solve the problem the same way. Instead of going back to, Aaron or whoever and saying like, hey, I need more than a 40. Give me a 36 or give me a 32, right? And give me more address space. More than likely, they rounded up to the next largest nibble boundary for you anyway in terms of a reservation. So it's probably pretty easy to ask for that. But everyone goes in asking for far too little space. And I can give you pragmatic examples of that. Like we were working with a very large SaaS provider, and their initial allocation was a whopping 36 from one of the other parts of their organization. And this is the corporate network side that we're dealing with. Their production side is entirely different. And their production team handed their corporate team a 36. We got done doing all the work for them in the analysis, and we came back and said, you need a 28, right? And the reason why is for bring your own address space for public cloud, for all the IoT stuff, for all the build configurations they want to do, for container networking, for all these other related items that are just future planning. 10 years down the road, whatever, 30 years down the road they need to plan for. I'm like, yeah, you need a 28. And we went back and resubmitted all the paperwork, and Aaron agreed. They're like, yeah, that's all legit. That totally makes sense. We're going to give you a 28. So they went from a 36 to a 28. In terms of
probably
size.
In about a week. Usually that kind of stuff, if you've got the paperwork done, it's not.
Yeah, it took a bit. Surprisingly enough, the thing that took the longest was for their finance team to get around to actually issuing a purchase order for Aaron to get stuff. So we sat on it for a month and a half waiting for all the paperwork on the backside, even after all the ticket was actually agreed to and everything else. So you're right, Nick. It didn't take that long from a technical standpoint. It took a lot longer to get the actual, approval and the VPs to sign off, because Aaron requires, like executives to sign off on your statements and everything else. So. But yeah,
I've seen V6 requests. This is a tangent, but it's interesting. I've seen V6 requests into Aaron turn around in 24 hours.
Yeah, if it's
24 hours, and here's your allocation. So it's not hard to do.
You have to be able to articulate it, and you have to know what your use cases are, and you need to do some thinking about it. And I think that's, to the great folly of everyone. This is where IPv4 thinking is going to absolutely kill you. It's going to kill you because you don't understand what to actually ask for, because you haven't had to go through the exercise of doing that. And everyone on this podcast has gone through the V6 exercise and probably is, much more free thinking about that. I would say the vast majority of our V4 colleagues are going to be very stymied with that. And if they haven't gone through some sort of process with other individuals around that to sort of open up their eyes about what's possible and how they should be thinking differently, it's going to be a struggle. And then they're going to default back to, I can't ask, I don't have a legitimate reason to ask for more than a 48, right? Or something ridiculous like that, or a 40. And then I need more networks than what that's providing. So clearly I can't use my global unicast address space the way I want to. So guess what? I need to NAT translate, and I need an address space to use internally, and they fall back to ULA. And here we are again, talking about the exact same subject, as opposed to addressing the problem on the front side, which is really you just didn't ask for enough address space, and probably significantly under asked about how much address space you really need to be able to acquire.
Yeah, and I think that's a good dovetail into the next thing, which is You kind of touched on this, Ed, where, some of the things that we're doing now don't have the appropriate resources assigned to them to be able to successfully and efficiently perform these tasks. And I'm talking about two different things, right? You touched on the documentation space. That's a /32.
Yeah.
For anyone that's running a network like a service provider backbone or a large international company, you may have something larger than a /32. You might have a 28 or whatever, right?
Yeah, 24 even.
How are you going to write documentation for something that's bigger than a 32?
Yeah, you can't.
Yeah.
It's
without using space that's basically being, without squatting on unassigned space inside, the entire block of 128-bit addresses.
Yeah, I
essentially cannot do this.
Yeah, I agree, and I would like to see a larger allocation, whether that's the 2001 DB8 extended to be larger than a 32 in some capacity, so that we can really talk about documenting more complex network topologies. I would prefer to see additional prefixes so that you can see, you can very quickly recognize different, documentation prefixes that could be utilized in different ways to represent different networks in a more unique way, whether we reuse the old 6-bone address, the 3FFE. So when you're looking at a network topology diagram, you can quickly look and see 2001 DB8 over here and see 3FFE over there, and that's supposed to really represent a different network altogether, maybe a different service provider, different backbone, different partner appearing network. I feel the same way I think we need at least 3 of those because, it seems like that's the sort of industry default standard, just have at least 3 unique address spaces to do something, there, just to be able to identify within a page or a diagram or even, sort of sample configurations. That's what I think.
We have that in V4 as well, right?
Yeah, we do. V4 is just such small address space that no one uses it because it's pretty much functionally useless, right? It's a /24s. There's a bunch of /24s. No one has just a small /24 network of trying to stitch together. So functionally, everyone just uses RFC 1918 space to express their documentation, even though technically that's not what it's there for.
Right. I'd be so bold as to say that most people don't even know that documentation prefix exists in IPv4.
Can you name one of them? What is it? 192.0.20/24, I think is one of them.
Yeah, that's the one I use. And I actually just had to switch out of it. And I can't use RFC 1918 for hashtag reasons. But I had to switch out of that because I ran out of space for a lab that I've built. So it's totally.
I believe that's also widely deployed for on routers for black hole routing purposes. If you go and read documentation for how to build a black hole routing configuration in a router, it's almost always going to use 192.0.0.2.
Yeah. So if you're labbing up something that, has, black hole routing and you're following the BCP for black hole routing next hops, which uses that space. And, for V4, it's just a mess. And I feel like with V6, we've kind of gotten ourselves, not to the same degree, but in a similar way, we've gotten ourselves where
I think we just artificially constrain ourselves. We have real constraints in V4. Like this is
exactly
there's actual address limitations and how much space we're trying to recover, and there's all sorts of weird proposals out there for trying to carve up and claw back address space that probably is so polluted I would never want to claw it back. But
we just recorded on that recently, actually.
But I think the practical reality is that we absolutely have the address space available in V6. It's just the onus is on us to go make the request as operators. And this is where I feel differently than some of the peers who are writing maybe on the other side of the ITF, who are really much more architecture related people. And huge respect to them. They've done a great job with the protocol and getting it this far. And so, I'm not going to speak ill will about any of that. I wouldn't have a career without that. So, God bless them all for spending the time and effort to do so. But I think from the operator standpoint, we have a unique opportunity to step in and really say, we need more address space to be able to represent a bunch of different things. I think labs are super important. We need to be able to have and that's the second one that we're talking about, documentation than lab address space. And they serve different purposes. And that's why there are 2 different proposals out there to talk about documentation space versus lab space. And there's some unique opportunities within lab space to do pre-allocations or company-wide registration allocations to do things that look a little bit more like how we, assign MAC addresses, right, to manufacturers to be able to utilize to, publish and push things out there. So we have unique, Ethernet capabilities on a network. I think there's an opportunity to do something very similar within the lab address space, to assign stuff out to companies that actually want to be able to guarantee that they could spin and operate a given lab. Like Chris, you work at Zscaler, and Zscaler decides they want to spin a lab inside of AWS, and they want to guarantee for all their customers they can hit the button, deploy it. They're going to use the same address space over and over again in a lab prefix space, but it's guaranteed that if they want to run Zscaler with, whatever the other adjacent lab that they want to run with it, Okta, whatever else, you'll never have a conflict. It'll always work across from that lab address space to the address space they want to use for something else, along with a service endpoint for additional lab that they want to use there inside of AWS. It'll all work together with that address space guaranteed, because Zscaler actually owns that portion of that lab address space, right? It's assigned to them for that specific purpose. You're going to see the address over and over again. That's okay. And you have to manage your lab address space, but it guarantees uniqueness for deployment of services, regardless of which public cloud you use, regardless of which private cloud on-prem you might have for an agent, things like that. That guarantees your customer can run this lab demo without, having the problem that we all have today with IPv4, which is, I used the 10.0 address space, and it's the exact same 10.0 address space that Cisco deployed on. It's the exact same, lab address space that, Palo Alto deployed. And they're like, none of my labs will work together because I have to nap between all of them, or I have to run them as independent space for all of them, because they're all using the same address space over and over again, which is the exact problem that we have in public cloud today. Everyone deploys their VPCs in AWS, and they hit the button with the exact same 10.0 address space over and over and over again. It's whichever one was documented in the last, deployment guide from AWS, or the most popular one that everyone Googles, right?
And the other thing too, to kind of loop this back around to ULA, is that you can't use ULA for this lab space because all the reasons we just said. It's depreferenced. It's not going to work the way you think it will work if you're running dual stack. If you're running, IPv6 only, sure, maybe if you don't have any Windows systems in the mix and all of the operating systems and specialty devices that you're labbing up actually honor it correctly. But ULA just doesn't work for labbing for so many reasons, because 9 out of 10 people that are going to spin up a lab that need to test V6 are going to be doing dual stack. 9 out of 10, maybe.
And they're going to take whatever and they're going to, and they're going to take the default settings for whoever set that lab preference configuration up, which is one of the reasons I'm advocating for lab address space, because if they've got address space assigned to them and they know it's going to be unique within that lab address space because it's assigned to a company, and as long as that company is managing what's going out there as pre-built labs, it pretty much guarantees that all the manufacturers can have address space that actually is non-conflicting with any of their other either partners or competitors. And it also guarantees that if someone wants to run a, proof of concept lab and test against all the, whatever suite of applications, they can guarantee that lab address space, all of them are available. They can test against all of them at the same time and flip back and forth, or have them all operating at the same moment in time. And that's a unique proposition that we don't have available to us at all in IPv4. It's just not possible in the same way to know that we can spin up a set of resources and not have it conflict. Otherwise, you're back to the drawing board. You're going to build different VPCs and build NAT configurations between all your VPCs if you're running in AWS or in the VNets, however else that's going to look. So that's my quick advocacy for the proposal for the lab address space. I think the documentation address space is a more obvious, that just makes sense. So I don't know why people would argue against that one, but who knows? We'll see how it goes.
If the listeners want to know more about this, there's been over the last year some active discussions on and off on the IETF V6 Ops mailing list. Easily searchable. You don't have to join the list. You can kind of go and read. And it is a little bit of self-promotion. It's largely been Ed, myself, and Chris, and a couple other folks.
Kevin
Myers, frequent co-host here.
Yeah,
pushing this through.
Yeah, Russ White as well. Yeah, Russ has been really.
And Russ White, yeah. I mean, there's a lot of people involved, people that you listeners probably know who they are. But there's at least some folks behind it, and if you want to get involved with that, great. If you just want to read it and throw tomatoes at us, that's cool too.
Just the soft tomatoes, please, not the hard green ones.
Yeah, not that.
So a couple of things in defense of using RFC 1918 address space in documentation. Having been involved in documenting for vendors, you're lucky you got that much.
Yes.
Yeah.
No, I get it.
But
that's a shortcoming or a constraint of V4.
Yes.
We don't have that constraint of V6, so it's ridiculous that we're, artificially limiting ourselves in that way. There's just no reason for it.
So as someone who I'm at best a dabbler in V6, right? I'm not engaged daily in operating like you guys are. But one of the challenges
him from the podcast.
Well, no, but I think this is important, right? Because one of the challenges is that that the temptation of the mental model of ULA from an IPv4 perspective is that I think it's exceptionally hard just as human beings to reason about the size of the numbers that we're talking about. So we perceive it to be a scarce resource. So I'm not going to ask for anything because I know there's no way I would have got that in an IPv4 world. I'm lucky if I can get public address space. When I was a young lad, I personally could have got probably a /24 when we first started doing this, and get it from Internic, get the email from Florida or wherever, or the email, the letter from Florida. So if I apply that same, how do I create the new mental model when I can't even reason about the size of the numbers that we're talking about?
Yeah,
so I think that the temptation is both.
Yeah, that's fair. And I think my argument back on that is you have to spend a little time educating yourself so that you get comfortable with what V6 is there. And I think to Chris's point earlier is, it's more than just address space, right? It's more than just more address space, I guess, in terms of that side of it. And I don't even worry about the address space discussion anymore. I just don't like talking about it because it's totally pointless in V6. We should only be talking about how many networks you want to operate. That's it. That's the only discussion that should be going on. And then based off of that, it should be how many places can you perceive that you need to operate networks in? Public cloud, IoT, maybe SaaS providers. Who do you want to hand address space for? And here's a really good example of something that's really interesting as a complete side note, maybe something we wrap on. But happen to know an organization, their security team is now familiar with the V6 project that's going on. Very large, very, very large public SaaS provider that absolutely everyone knows. And they're looking at this as an opportunity to say we don't like that when we spin up a new resource in AWS, we get some random Elastic IP that gets assigned that we don't know the reputation behind. We know it belongs to Amazon now, but we don't know what previous customer used this thing, right? It's tainted. It could have been used for something nefarious. It could have been used for by a security company to do probes for stuff against China. Who knows? You just don't know what it was used for. You have no idea what the reputation is, right? And they're
there's baggage,
right? There's a ton of baggage, and it's only getting worse over time. As opposed to what you can do with V6, which is I'm going to bring my own address space. So I'm going to bring my own address space, and every provider that we work through, they will use our address space. We will allocate them address space specifically for the purpose of our services that we will utilize and advertise from that, whether it's SaaS, whether it's public cloud, whether it's a partner. And we own the complete reputation of that address space because we own it end to end. It's been allocated to us as an organization. You can look it up in Aaron, it belongs to us, and then we will swip it over to whoever's required to operate it on our behalf. The only way those addresses get handed out is for our services that we run and operate as an organization. And if you think about how powerful that is from just a concept basis of what you own reputation-wise on the internet, that's a huge difference versus what you can't do that in V4. That is an impossibility to do in V4 today. It is not possible to do. It's 100% possible to do in V6. And I challenge people to think through problem spaces like that. It becomes very, very interesting. There's very unique things that you can do with V6 to help you solve these related problems that are just even if you want to talk about address space, just doing transactions. You assign a single /64 to a server and let it use as many addresses for as many transactions as it wants to do. You're never going to run out of addresses on that host. Ever. And we can do the fast math for you. Let's say you use 10 million addresses a second and never reuse that address. Out of a 64, how long is it going to take you to burn through your /64. And this maybe helps with the math for you, Chris. It's going to take you 58,000 plus years to burn through the 64 at 10 million addresses a second on a single /64 that's assigned to a host. So think about that. I don't think most
I've
people's
done the math a few times, but my reflex is not that.
right.
I guess.
And yeah, I get it. And so that's why I try and make this like a real world, like 10 million a second out of this server, which is probably not even possible to do. Like, I don't know that you could open 10 million a second, discard them, open another 10 million a second, discard them, and continue doing that like forever, and have that many transactions go on. But this is it's just a thought exercise. How many people believe their data center is going to be here in 1,000 years? How many people believe their data center is going to be here in 100 years? So 58,000 years versus your 100 years that your data center might be on the planet. Like, why are you worrying about how many addresses you have? Stop worrying about that, right? Because how many 64s do you have in a 48 that you should be assigning to a site or even just a small data center? 48 would be great for a data center just to have as a small, medium-sized data center. You got 65,536, right? That you can assign out of your 64s. And even that, I would argue, is 48 for a single data center is probably maybe not enough, depending on what your design and operations are. Well, take that number and multiply it by 58,000 years, and now you know how much you can operate on every single host with never repeating an address again. I don't know. It's just a different way of thinking about it. And this is why I say you worry about how many networks you operate, not how many hosts you have. And you don't worry about functionally even how many networks you need to operate from an asking perspective, because even the largest of the largest are starting to realize that they can ask for sufficiently large enough address space. We're working with most of the global 150 as a company, and I can tell you that the ask and the direction has changed dramatically in terms of what they're going for. We're completely off topic from ULA, but anyway.
Well, I don't think we are, because I think that this ties it and wraps it up pretty nicely with a nice little bow, in that a lot of the reason that folks look at ULA, at least at a very high level, is because they have a V4 mentality of, I need to make sure that I'm conserving resources, and I need to make sure that I'm using private resources where I'm using private resources. Well, we kind of went through and discussed what doesn't work with ULA and why they are not an analog for 1918 space. And you just very succinctly described why, thinking about resource allocation with a V4 mindset kind of doesn't make a lot of sense in V6. And so why not use global address space? Like, there's no reason to use ULA. You can just not route the global address space and you'll get consistent behavior. And you don't have to worry about, I don't know how many public IPs I've got left over. And, I've only got a /27 at this location, and, blah, blah, blah. I think that's a nice little rope-a-dope, whatever you want to call it, back to the point.
Closing the loop.
Well, my beginning statement and my end statement are the same. Don't use ULA.
Oh, and I think you made that case.
Yeah, I hope so.
I did too.
I think we asked the audience, like, hey, you guys give us feedback. Like, let us know. You got a ULA use case. We definitely want to hear about it, because, man, I struggle to find one that really makes a lot of sense. So if you got one that makes a tremendous amount of sense, I definitely want to hear about it.
And I'll give everyone Chris Cummings' personal cell phone number. You can call and tell him what those use cases are. Make sure to do it really late at night or early in the morning. That's how we'll do the communication. No, all seriousness, tweet at us.
Yeah, tweet at us.
This is a good stopping point, right? Tweet at us. Tell us what your use cases are, because we genuinely want to know. Because, like I said, there's several of us working on some of these drafts that, they're meant to address some of these shortcomings. And the more use cases we have that we understand in both directions, the better off that we'll be. So if you want to tweet at us, let's tell everybody where they can do that and where they can find us. Ed, where can people find you?
Twitter is @ehorley. So that's pretty straightforward. For the blog, I blog occasionally at howfunky.com. So so you can catch me on howfunky.com, or you can just hit me @ehorley. It's the best way to get a hold of me.
Also, check out his podcast, IPv6 Buzz. Totally worth your time. Lots and lots of great info. on
Thanks.
there.
We try. It's my co-hosts are far more entertaining and knowledgeable than I am. So shout out to Tom Coffeen and Scott Hogue, the two brilliant minds of the podcast. I'm just there for the sexy voice. So
no, it's always a good one. I enjoy that podcast quite a bit. And when I'm up to date, it makes me mad that there aren't new ones.
Thanks.
So Chris Cummings, where can we find you?
Yep, you can find me on the Twitter at CrankyNetman, and my cell phone address is 217. Oh wait, that's Nick's. Oh, hold on a second. Okay, yeah. You can find my IPv6 address at 2001. No, my blog at /64.tech, modem.show. I'm online.
And last but certainly not least, Chris Young. Where can we find
at Netman Chris on Twitter, and I keep paying for the blog, and occasionally, I look at it and wax philosophically as to when I will get back to that, and just look for more interesting things to find to write about again. It's I think the world is finally starting to get exciting again, so I'm looking to perhaps dust it off. So the blog would be controlissues.net, and I'm around.
Yeah, I hear you on the blog thing. I looked yesterday evening, and I have not written anything since the beginning of 2021. So right about the time that we started doing this podcast, the blogging, which is at forwardingplane.net, is the blog. There's some good info on there. A lot of it's dated at this point, but hasn't gotten a lot of TLC since we started the podcast. And you can find me. I'm Nick Braulio on the Twitters at Forwarding Plane, of course, modem.show, or Chris, you want to say one more thing? Oh, he had his hand up. I thought he had his hand up, but no.
I was waving to Ed because he's like,
thanks to Ed for coming by, and it's always good to hang out with cool people.
Yeah, man. Thanks for slumming a little bit with us, Ed.
I always love talking to my V6 peeps. So it's all good. It's all good.
All right. Well, thanks for tuning in, everyone. And we'll catch you on the wire.
Thank you for tuning into the Modem Podcast, where yesterday's modems are today's transponders. For more information or to request a topic, please visit modem.show.